So I asked the question in my last video whether or not the comparator could drive an LED, and well, that LED is on and the output is a little bit lower than we'd expect because we're on that side of the resistor, but okay, it is doing its job. Now the question is whether or not it'll go off when that comparator is off. Let's try that. So there we have, the LED has gone off, although you may not be able to see that on the camera. Let's turn the light off. So with the coil not being excited by the wire going through it, there's no LED on and there's no signal at the point of the LED. If I connect up the other wire, so hopefully you can see I get a signal on the output and the LED comes on. That makes my life a little bit easier for the next step. I need to wire this rat's nest through those coils. So I'm going to work out what sequence I have to put through the coils, and then I'm going to pass those through. So before I actually start with the wiring, I thought I'd test a circuit with the LED round the other way, and the reason for doing this is because the display packages that I'm going to be using ultimately will be common anode, and so the switching will have to occur on the negative side. So at the moment, with a signal going through the coil, the LED light is on and we get a signal on the resistor. So when I disconnect the wire for the signal and connect it to a different coil, we'll see if that LED still stays on. It might. Well, that's a little bit disappointing because the LED is still on, as you can possibly see. So even though I don't have a signal, the LED is on. Well, that makes sense. So what's basically happening here is that if the signal's low, the LED comes on. If the signal's high, it doesn't. Now the signal is low whenever there's no output, and so the LED comes on. This isn't going to work for a common anode display. So the question is, do I have a common cathode display I can use, or am I going to have to invert the signal? I don't have any common cathode 7-segment displays. They're all common anode. So you connect up the power to, well, the positive power to pins 3 and 8, and then we can poke about with the LEDs by grounding them through a resistor. Which is what we're stuck with. So I am going to have to invert the output of the comparators in order to get the LED to light up in the order that I want. So I'm going to mess with that before I do the wiring through the coils, just to make sure that it does work. And while these chips didn't come from AliExpress, I'm not going to spend hours and hours trying to figure out why a circuit doesn't work, because the chip doesn't work. So we'll test it. And that one's okay. So I've rewired the output through a inverter, I hope, which is this here, to the LED display. Now at the moment there's no signal coming through this coil because this is the wire that I'm using, and this wire doesn't go through that coil. So that's kind of what we want. And we can see we've got a very low output, weird output. Huh. Well, let's see what happens when we put a signal through the coil and see if anything comes back on. Hopefully it will. And there we go. We can now see we've got an LED on. The LED isn't very bright, but that's okay. That can be easily rectified by using a different value resistor. I think the resistor is like a 3K or something, so it's way too high. In any case, that seems to work. No signal, no light. Signal, light. So the inverter here is inverting the signal from the comparator. It's also acting as a bit of a buffer. The annoying thing with these inverters, a 74HC04, is they've got 6 inverters on them. 7 segment displays have 7 segments and a full stop, which means I'm going to end up having to use 2 of these chips to get all the segments lit up, or use a transistor for the last segment or something. So we've wired through all the wires coming directly from the MUX board through the coils. I've ignored this one, which is essentially going to be the full stop for the time being. I've still got to connect up the 4060, which has come untethered, and then I've got to set up the inverters from all the outputs over here through an inverter, or possibly a second inverter, and find some resistors from somewhere that I can use as pull down resistors. Yeah, so not much to do. I've made a few modifications to the board, to the proto board. I've stuck a transistor in for the final digit, for the final LED on the 7 segment display, because I didn't want to put another 7404 in just for one LED. Seems a bit excessive. And the other thing I've got on the board is a resistor pack. These packs have 8 resistors in them, and it's just going to make life a lot easier connecting the LEDs up to the signals using a resistor pack rather than lots of individual resistors. I'm already using one, as you can see. So this is the transistor. I think it's just a 2N3904, which is a cheapo NPN transistor. I haven't spent a great deal of time choosing the biasing resistors. I've literally just picked up a couple that were on my desk. The signal from the comparator is coming in through the resistors and then going to the base of the transistor. The emitter is just connected straight to ground, and the collector is connected via this resistor pack through to the LED to bring the LED on. Now, as you can see, currently the light is on, and that's because there is a signal on the line, as you can see. If I disconnect the signal, we can see that we've no longer got an input signal, and the LED is almost completely off. There is a little bit of light still coming through it, and that's because I've just randomly picked bias resistors for the transistor. If I'd spent a little bit more time on calculating a value, it might have worked a bit better, but that's fine. It's good enough for what I'm going to be trying. So the next task then is going to be to wire the rest of the resistor pack up, the inverters for the 6 other segments, and the outputs of the comparators. It's quite a few wires. So at the moment, the blue signal on the screen is showing the output that I want from the comparators, which is a nice square wave, which should bring on the LEDs on the 7 segment display. However, if I move it over to a channel that doesn't have the signal, or shouldn't have the square wave signal on the output, I get a lot of noise, and that noise is still switching on the 7 segment display. So that's a very messy signal. So what I need to do, or what I'm going to try and do, is I've wired up a small variable resistor here and a capacitor, and I'm hoping I'll be able to just reduce this down a little bit, or reduce the blue signal down a bit so there's not quite so much noise, or at least the noise is at a lower level, whilst still working on the square wave output when I want an output, if that makes sense. So I've got this wire here, which I'm going to plug into where I've got the scope attached to. The other end of that wire is going to a capacitor, and the capacitor is going down to ground. So essentially I'm creating a small RC circuit. Do I really want it to go to ground, or do I want it to go to the high? I don't really know. Let's try ground anyway. We can see that's gone off. That's good. If I twist it a little bit, it comes on. I would suggest that I just twist it so the light just comes off, so about there, and we can see the signal's much lower on the scope, which is great. So the wire that's currently plugged into this wire doesn't go through channel B, but the other two wires I've got here do, so I shall pick one of those. And the light still isn't coming on, and I want it on. So I'm just going to twist it back again. So there we got a signal on. Now if I go back to the other one, the other wire that doesn't go through the coil, it's off still. Well, that's exciting, isn't it? The difficulty I've got, or the difficulty I'm going to have, is I need 7 of those resistors, and I don't know what value that is. I don't know how close that value needs to be, because that was pretty sensitive, getting it to turn on and off. Essentially there's a very small window between it being off and on, so what I need to do now is basically measure that resistance value and then see if that's anywhere near a standard resistor value. Can I do that when it's plugged in? No. So the sweet spot apparently is 1.4 kiloohms. There's no such thing as a standardised 1.4 kiloohm resistor. However, there is a 1.5 kiloohm resistor. So I've just got a bundle of them, and we'll see if any of these are anywhere near close. Not that I'm suggesting I pick out only 1.4 ohm. That one's probably close enough. So what I'm going to do now is I'm going to replace the variable resistor with this. So that's what we've got with it supposedly off. Let's transfer it over to supposedly on and see if it comes on. And it doesn't. Okay, so the reason that didn't work is because I used a 150 ohm resistor, not a 1.5k resistor. That'll teach me. Pick out the right packet. So that's 150. No, that's not. That's a 1.5k, the correct resistor this time, and we can see it shaped the signal, but the light's still on, which is grand. So if I move it over to the signal that shouldn't have the light on, the noisy signal has been reduced sufficiently to turn the light off. You are able to see these lights are on and off, aren't you? Let me just, if I hover over it, you can see the lights off, I think. And if I plug it back in again, the light's definitely on. So we can see here on the red channel, the signal's up at 5 volts ish, I hope, and that is why the LED's off. If If I move it over to the one where it should be on, we should get a different signal. And what we're getting is mostly on, but sometimes off. I'm surprised that's coming on at all, if I'm honest about it. Basically, the LED is off for most of the time. And it just illuminates occasionally. Okay. So if I put a sine wave in, it basically does the same thing. And if I move that over to the off position, again, the same thing. That segment is operating in the manner that I'd expect it to operate. Now I'm hoping that if I replicate that for all of the 7 segments, they'll all behave the way that I want them to. So I'm going to go off and do that right now. So with a bunch of resistors and capacitors down here, I think the resistors are 1.5k or thereabouts, and the capacitors are 470 nanofarads, I think. On the signal that misses A and goes B, not C, D, not E, and F, you can see we've got the 3 signals on, 3 of the 7, in fact. If I move over to another signal, which I don't know why that's coming on, that's interesting. If I move on to another signal, I would suggest that's the one that's going through all of the coils, and that's bringing up all 8, which is what you'd expect. And if I go to the final signal, that does A, C, E and G, which is also what I'd expect. Now, I haven't done the capacitor and the resistor thing because that's using little transistor here. And the reason why it's slightly less bright, don't know if you can see that, is because I've not got the biasing right on the resistor, I don't suppose. But that's okay, I can live with that for the time being. So that bit's working. Fantastic. So this wire here is the signal wire for the 7467 multiplexer. So instead of putting the signal generation into these wires here, which just go directly through the coils, if I stick them through the multiplexer, we should get a different sort of output. I wonder what happens if we do that. And we get nothing. I am getting a light on this bodge board here, so this light's on, but there's no sequencing. I wonder if my sequencer is sequencing. Right, so I've got a slightly reorganised desk. So you can see that this LED's on. You might be able to see that LED's on. It is on. But this should be sequencing through these, and it's not. I'm going to have a look at this one at the minute. So the question is, am I getting a signal to these 4 wires here, which are the line signals for this multiplexer? So if I plug this in, okay, so I'm not getting a signal. Am I doing something wrong? I think I've spotted a slight problem. I've been feeding in a sinusoidal signal into this bodge board here, the 4060. Only I've been feeding it in at about 15 volts. So I may have fried that. That's slightly annoying. That being the case, I wonder whether or not I can manually use the switches again, just to see whether or not this is going to switch. I don't know why that's coming on its own. I don't know why I haven't got an output. So that's not working either. So what I think I'm going to do, because I think I may have fried this little baby as well, try just sending a signal down one of these wires on its own. The difficulty with that is going to be that I have to disconnect all these so that it doesn't get a signal from here. I wonder if I can just inject a signal. So at this stage I'm a little bit baffled as to what's actually broken. I'm fairly certain that I've popped the 4060 by sticking 15 volts into it. That's my bad, completely. I don't know what this is doing, and I don't know why it's not doing what it's supposed to be doing. And I don't know whether or not the LED circuits are causing a problem either. I mean, I can stick a voltage on, oh no, that's a signal. Oh, a voltage. I can stick a voltage on 6 and it produces the number 6, sort of, and lights up the LED. It sort of works. I can stick a voltage on these and LEDs light up and some segments light up, but I'm not convinced it's doing what I expect it to do. Basically, I think the solution at the moment is to remove this board entirely and maybe test it outside, and to remove this LED board, and essentially have the cables that are threaded through the coils entirely separate and then test them individually, and that way I'll know whether or not the display circuit's working or not. At the moment I'd say not, and I'm not entirely sure why, because it was working. So I've removed these bodge boards, so that's the LED board and the multiplexer and or 4060 counter boards. So they've just been removed from the circuit entirely, and I've replaced them with 2 sets of resistors. So we've got 50 ohm resistors at this end, and that's the termination end of the coils, of the wires going through the coils, and at the other end I've got 1 kilo ohm resistors just pulling them down to ground as well, so that whenever there's no signal on the wires, they're pulled low. And the brown wire here is my 5 volt supply, and I'm just going to stick it on each of these little sockets down here and see what lights up on here. If I've got it right, there'll be numbers. If I've got it wrong, it means I've got the sequencing through these coils wrong. That's not going to be fun to sort out. That don't work. I hate my life. In terms of function, it is doing what I'm expecting it to do. I stick a signal on one of these wires, and depending on which coils the wire goes through depends which LEDs come on. Now obviously this is not a mess in terms of wiring, and maybe that's the problem. So maybe what I need to do is just start again with this circuit and rewire it. That doesn't fill me with joy, you understand. Essentially the circuit is working, but it's just not working right. And it's not working right probably because of a wiring issue. Now I know everything on from the coil side works because we've tested that before, and I can prove it again by
if I touch the signal generator on, so I touch the signal generators onto one of the blue wires that goes through the coils. This one's going through three of the coils that are lit up there, so that'll be the even coils, I suspect. Yeah, A, B, C, D, E, F. So those coils are wired up correctly. Yeah, if that makes sense. Now, if I'm correct, there are two more blue wires, one of which will light up all eights. So let's try one of those. No, not that one. So that one goes through all the coils and should light up all eight, and it doesn't light up that one, which is probably a fault with the circuit on this board, because it definitely goes through all of them because we've seen it working before. That one lights up A, not B, C, not D, E, not F, and G. So that's working. So that's the first one. Yeah, this one here is not lighting up as well as the others, and I'm not entirely sure why. But we can definitely see that the coil circuit is working. What's not working is this board, quite the way I expect it to.
If I put a signal in, is that what I'm doing wrong? So it sort of works, sort of. I think I might have a wiring issue. I might need to rebuild this board. So I've rebuilt it. These are the wires going off to the coils, and they come back through these coloured wires here. And they're different wires, coloured wires, because they go through a terminal block. Okay. At each end there's termination, so there's 50 ohm termination on the blue end, and 1k termination at this end. Both sets of resistors pull the lines down to 0 volts, and the purpose of that is that when there isn't a signal on the wires, they're grounded, and that hopefully will do away with any possibility of picking up stray signals from anywhere. Now I've replaced the one off transistor with another 7404 sort of hex inverter, and so there's now two of those chips there. Ooh. And a dodgy connection. There's now two of those chips there, plus the resistor array here, which is used to limit the current to the LEDs on the 7-segment display. You can see that if I block out the sun, okay, so there we go, I'm blocking out the sun. You can see that one of the displays, the centre one, is coming on. I don't really know why. I wonder if it's something stupid. If I just ground all of those, that'll go away. It'd be very nice if it did. So it seems that the old blue wires, which weren't being used, here they are, just in the corner here. I'd earthed them, I'd grounded them, and it didn't like it. And I'm not entirely sure why. I probably should have terminated them. I don't know. I don't know why that was doing it. But I will have to think about it. Still got one that's on a little bit dim, but if I work my way along, we'll see if we get any numbers coming out of it. So the first number is 0.
Good start. The next number is 6. I kind of think I've got some wires mixed up, but never mind. We've got C, possibly E. Let's call it C. Number 1. E. D. 4. F. 6. 5. A. 7. 8. And then nothing on that one. So that's interesting. 9, nothing on that one. And then that was the last one. So those might be broken wires, or wires that aren't plugged in properly. That's 9.
So 9 is the last one, in fact. It's that one that doesn't work.
3 works, 8 works, 7, A, 5, 6, F, 4, D, 1, C, 6.
And 0. So I've just got one that isn't working, which is that one. Alright, so the question is, why isn't that one working? So it's a red wire, and there is number 2. I'd managed to forget to connect up one wire, of course. So, notwithstanding that the order of the oh, I'm going to have to put them in the right order, aren't I? So a quick, and by quick I mean painful, reordering of the wires. We've got 0, 1, 2, 3, 'It works! So this completes this video, I think. And I've completed everything that I've actually wanted to achieve this time. It's a shame that the multiplexer didn't work. So the next video I do will be reintroducing the multiplexer so that it can just count along there for me to save me having to do it manually with a wire.